So last year at ElixirConf, oh my God, yeah, okay. So last year at ElixirConf, I said that there was one last planned feature for Elixir. And this feature was mixed release. And it was released this July, last month, with Elixir 1.9. So, okay, so what I'm going to do, I'm just going to go for it, flicking or not, and we're going to make this work, okay? So, it's a big font, yeah, it will be entertaining. All right, so, so mixed release, okay? And the idea with mixed release is that you can get your whole application, its dependencies, the Elixir programming language, the Erlang virtual machine, put everything into a single directory that you can get and run it in production. So just ship the whole directory and everything is going to be there, right? And last year when I was talking about mixed release to me was always part of something bigger. Because what I had in mind, my goal for 2019, for this last year that passed between the ElixirConfs, was to streamline, now the slides aren't changing. Okay, there's a delay. Is to streamline Elixir in production, right? And what I mean by streamline is to make the process as frictionless as possible. Because, you know, we can run Elixir in production just fine, right? We could do that last year, could do that the year before. Even before Elixir 1.0 came out, there were people, companies run Elixir in production. But my goal was to streamline the process, remove all the friction. Like, you know, the same way that we try to remove as much friction as possible from the development experience, from the testing experience, we want to do so for our production as well. And as you're going to see, we are just building on a lot of the knowledge and the tools built by the community. So our agenda for today, we're going to talk exactly about this goal for 2019. I'm going to talk about what is next for Elixir, and then I'm going to be a little bit selfish and talk about what is next for me. So let's do this. Goals for 2019, so streamline Elixir for production, and one of the ways that we are doing that is by adding releases. So how do releases work? So today you can create a new Elixir application and build a release and run that release in 4 commands, right? So you say, hey, I want to create this new app, and then you go to that app directory, you run the mix release command, and that is going to create inside the _build, the environment, rel, my app, inside the directory is going to be your release. And if you want to start your release, there is an executable at bin/my_app, okay? There is this executable that's like the front end to the release. You can do everything through that executable. So what can it do, this release executable? It has the start, restart, and stop commands. So we can start it, we can stop it, we can restart it. It also supports RPC commands. So if you have a node running and you want to ask it to do something, we can connect to that node and do that. We can also have a remote console. So if you have a node running, you can actually connect and have a IEX and run code directly against that system, that node, if you want to. There's also support for one-off commands. So the idea of one-off commands is that sometimes you want to do something not against a live system. Just do something very quickly and terminate. For example, running migrations, right? You usually want to run migrations before the system starts, so you can do that as well. There are built-in commands to install as a Windows service, okay? And there are built-in commands to run as a Unix daemon. It's there. All right, and I'm just going over the bullet list of what you can do and what you cannot. We wrote So you do not need to rely on those slides at all, because as usual, we wrote a lot of documentation. So if you go check out the documentation, we talk about everything and more, right? And we also use this opportunity when we're working with releases to streamline a little bit more how is the configuration experience with Elixir, because it's actually, when we're talking about configuration, it's actually a little bit complicated because there are just too many different places that you can configure things, right? You have to configure the OS, you want to configure the virtual machine, you want to configure your build system, you want to configure like the system at runtime right before you start it. So there are all these different kind of configurations that you could do, and we did not have a lot of guidelines on how to do that. So we used releases as an opportunity to do just that. So we have 4 kinds of configuration. So you want to configure the OS. So there is a env file that are going to configure the OS. So if you need to start something alongside your system, or if you need to set some environment variables, there's a file to do that. If you want to configure the VM, there's a file for that as well. If you want to, and then the usual config files that we have today in our app, like config/dev, config/test, that's the build time configuration. That configuration applies when you are building the software, so it applies in the system that you're building, right? When you're building the release. And then we have this idea of runtime configuration through something that we call configuration providers. And that configuration runs on the target system just before the system starts, right? So now we have very explicit steps and instructions of where you're going to do each of those. Right, so again, I'm not going to go into a bunch of detail. You can run mix help release to get the documentation in your terminal, or just go to the website, and we explore all this there. And of course, to get releases into Elixir, there is a bunch of work from a bunch of different people. So the first thank you goes to the Erlang OTP team. So a lot of the features in releases, they are just there in Erlang and OTP, and we are just wrapping them. So, installing as a Windows service, yeah, that's implemented in OTP. Running as a Unix daemon, yeah, that's there as well. So we're just wrapping it. Also, a huge thank you to Relax, to the Relax team, in particular Tristan. So one of the reasons that before the conference, I was looking like my old documents, like what I wanted to have in Elixir 1.0, and releases was there, right? But it took us a while, right? It took to 1.9. And one of the reasons for this is because even the Erlang community itself was kind of like figuring out how they want to best do releases. And a lot of this process of figuring out happened in the Relax project. And Tristan was also really helpful with reviewing the code, exchanging ideas while I was implementing releases. Also, a huge thank you to Paul with the distillery project. So, if you want to do before 1.9 and even today, right, if you want to build releases in Elixir, you can use the distillery project. And Paul is the person behind this project. And also, thank you to Dockyard. So in 2017, Brian was here on stage. He said that he wanted to focus on the production experience as well. So he ended up hiring Paul to work on Distillery 2 and a bunch of and when Paul was working on Distillery 2, he tried a couple different ideas, and some of those ideas they made into Elixir releases. Also, just a quick thank you and a heads up. There's this amazing project called Shell Check, which is a static analyzer for shell scripts. And it's just amazing because, for example, when you're working on releases, we have to write I had to write like 500 lines of shell code. I have to write like 500 lines of MS-DOS batch files. It was amazing. And when you're writing the shell files, you want to write it in a way that works across all Unix systems. And shell check helps with that a lot. So we like it so much that it's even a part of our CI now, of the Elixir CI. It's checking all of our scripts. And finally, a thank you to Platform Tech and the Elixir core team for all the help and feedback and exchanging ideas. All right, so that's releases, okay? And it's out there. If you're running Elixir 1.9, you have releases today. You can just use it. But we also worked on something else during this period. We worked on a project called Telemetry, right? And I want to tell you a little bit more about Telemetry. So one of the things that attracted me to the Erlang virtual machine at the beginning was the amount of information that we can get from a live running system. And one of my favorite stories about being able to get information and introspect and debug a live system is the story when we're able to get 2 million connections on a single machine with Phoenix. So this is probably already 3-4 years old. You probably already heard a couple times. So, but the story is we're able to get 2 million connections on a single Phoenix instance via Phoenix channels, okay, WebSocket connections. And Gary was the mastermind behind the benchmark, so he was able to get like 50 machines to coordinate, to send traffic to a single server. And when we started doing the benchmark, we were able to get only, I think, 30,000 connections, which is way below 2 million, way below the value we wanted to get. So we're like, well, I guess that, the first thought that came to our minds that we probably have a bottleneck in the system because we had a very powerful machine with, I don't remember, but like 96 cores or 128 cores. So we thought, well, I think we have a bottleneck. So what we did at the time is that we started this tool called Observer. That is a tool that ships with the Erlang virtual machine. And this tool is able to list all the processes in the system. And then you say, OK, I want you to list all the processes, but I want you to tell me, to show me first the process with the biggest message queue. So I want to order by message queue size. And then we're able to see that there was a process that the message queue size was only growing and growing, which meant that there was everything in the system was trying to talk to that process, and that process could not keep up. That was the bottleneck. So we were like, all right, that's the problem. We solved the bottleneck, and then we benchmarked again. We found the next bottleneck, and then rinse, repeat. And then at the end, we're able to get this graph that you can see here, where we're able, with time, to get to 2 million connections. And what is happening here is that we are accepting a new accepting 10,000 new WebSocket connections per second until we got to 2 million. So really amazing, right? But even having this tool, we would hear from people say, hey, we're running Elixir in production, but it's like a black box. We don't know what is happening inside. And then to me, it was always a little bit puzzling, right? Because there's so much information about the system. How can it be running as a black box? And the issue is exactly, sure, the information is there, right? But how can we get that information out of the system, right? And put it on my dashboard. So that's exactly the goal of the telemetry libraries. Okay, so it's a collection of libraries. The first library is called Telemetry. And Telemetry is, these libraries like super, super small, I guess 3 files, 3 modules. And the goal of this library is to be an event dispatcher. So all it does, like you say, oh, a query happened, and it took this long. Boom, you send a telemetry event with that. Oh, there was a web request. You send an event with that. You can also send like your application metrics if you want to. Oh, a user signed up, right? So it just sends events. It doesn't know what we're going to do with those events, right? And it's very small on purpose because we want everybody to depend on this library to start emitting those events. So that's step one. We need to get everybody to start emitting events. And then we built the telemetry puller library. And the idea of telemetry puller is that there are some information in the system that it doesn't make sense to emit events for them, but we want to have this information anyway. For example, like memory, right? It doesn't make sense to emit an event every time there's memory allocation. So what we do is that every 5 seconds, every 10 seconds, we check how much memory you're using, and we emit an event. So now we have all those events happening in the system. We need to try to come up with a way of understanding those events, of aggregating those events, of making something meaningful with them. That when comes the telemetry metrics library. And that describes how we're going to consume those events. So, oh, I want a distribution of those events. Oh, about this event, I'm only interested in the last value. So you describe now how you're going to aggregate and consume those. And finally, there is a group of libraries called telemetry reporters. And the goal of those libraries is to get exactly those metric definitions and push it to StatsD, Prometheus, Grafana, New Relic, Scout, AppSignal, whatever, right? It sends the information to the system where you can finally visualize what is happening in our system. All right, that sounds interesting, but what does that mean to us, developers, right? We just want to write our application, we want to have it run in production, and we want to have nice monitoring, observability dashboards, right? So how can we do that? So just to show an example, So our hope is that in Phoenix 1.5, but you don't have to wait for Phoenix 1.5, you can do this today, okay? But with Phoenix 1.5, as an example, it's probably going to ship with a new file in your application, which is called My App Web Telemetry. And what that file defines are exactly the metrics that you are interested on, right? So for example, it's a supervisor, and then it's going to have a metrics function. And in that metrics function, you're going to say, look, there's a delay. Look, I have those VM metrics, right? And those VM metrics, we have the total of memory that is in the system. So I am interested in this metric, okay? So this is something I'm interested on, right? I'm also interested on the total run queues. The run queues is something that you can use to track if your system is overloaded. If the run queue is only growing, it's because that system is getting, it's overloaded. It cannot handle with the amount of requests, of the amount of data, whatever that it's getting to it, right? So you need to or add more machines so you can scale horizontally, or you need to have more powerful machines so you can scale vertically, right? But so it's something very important that we want to track. Maybe you have some important worker that you want to track the memory or the message queue. So this is just saying, I have all those events in the system, and I'm interested in those events exactly like this. So those, I'm interested in the last value. So in your dashboard, it can be just a number, right? Or it can be just a graph that is showing the last value. But you're also talking to the database, and the database has a bunch of metrics, right? So for example, how long the queries are taking, how long you're waiting for the queue, and for those you want to actually show the summary with a little bit more information. You may want to do some histograms. So the idea is that the metrics will be happening, and you have a way to collect that, right, and send it somewhere. And exactly, to send it somewhere, what you need to do is that after you define all of the metrics in the system, say, okay, now I want to start a statsd reporter that is going to get those metrics and send it to statsd. Right? We're like, okay, but Jose, I don't want to use statsd. I want to use Prometheus. Sure, replace statsd by Prometheus, and then the data goes to Prometheus. Maybe you want to use both. Sure, list both in there, and list the metrics that you want for each. Right? So our goal with telemetry is to have metrics for all, right? And I think we are really, really close to get to this goal. So it doesn't matter if you are just starting up and you want to have some dashboard and some kind of feedback, or if you're a big company that already have all your infrastructure and you just want it to work. That's why it should work for everybody. But this is all very exciting, and we did a lot of work in terms of infrastructure, in terms of foundation. But there is still a lot of work ahead of us because we worked on telemetry, the pooler, the metrics. But now we are in the problem that we need to write a reporter for statsd, one for New Relic, one for Prometheus, right? For each kind of possible integration there is. The good news is that when we were thinking about this problem, well, we have to implement all of those different reporters. It was about the time that the Erlang Ecosystem Foundation was announced. And disclaimer, I'm on the board of the Erlang Ecosystem Foundation. And the way the foundation works is that we have a bunch of working groups that have very specific goals. So we have a marketing working group, we have a working group for security, and we also have a working group for observability. We have an observability working group, and their goal is to evolve the tools in the ecosystem related to observability, such as metrics, distributed tracing, and logging, with a strong focus on interoperability between bin languages. So this is perfect, right? So the working group was announced, and we're like, hey, we're working on this telemetry library that is completely aligned with the goals of the working group. Let's work together. And we started working together. So everybody in the observability working group started to contribute. So one of the changes that we did, for example, is that telemetry has been written to Erlang. So before it was written in Elixir, but the issue with it being written in Elixir is that an Erlang library would not use it, right? Because they would have to bring all of Elixir as a dependency, and that's just too much, right? And the goal of telemetry is to be small, so that kind of defeats the purpose. So when we rewrote it to Erlang, it means that all the bin languages can use it. And it's a benefit for us in the Elixir community because now, if you're using Erlang library, there is a chance that they're going to be using telemetry. Or you can ask them to use telemetry, and you're not going to be asking them to add Elixir as a whole as a dependency, right? So this is great. And they started working on a bunch of different reporters. So Yeah, so a lot of exciting things happening, and of course, I have a bunch of thank yous to say as well. So the first one is, so when I was saying, well, we implemented this, that was a lie. Who implemented all that was Arkadiusz Kiel. So the story here is that last year, Chris, he said in his keynote that we wanted to kind of have this metrics for all as a goal. And the folks at Erlang Solutions, they came to Chris and I, and they said, look, we're actually interested in that as well. Let's work together. And then what happened is that Arkadiusz Kiel, we started working on all of those libraries. And I was working as a mentor. And yeah, so those are the thank yous, and also a big thank you to the Erlang Ecosystem Foundation, in particular the Observability Working Group. So if you like to get involved, if those things, exactly things that you like, I recommend to reach out to the Observability Working Group in the foundation. So if you go to the foundation website, there's like a page with all the working groups, and then there's a chair of the working group, which is the person responsible, so you can reach out to them and say, hey, how can I join, how can I participate, okay? And yeah, and they're also going to have a talk on the foundation tomorrow. And you can also talk to me, Miriam, and Desmond. Where are you? Yes, so they will be around here. You find us, tweet at us, we'll make it work. All right, so before I go to the next part of the talk, which is what is next for Elixir, I just want to do a quick demo. I don't want to abuse of my luck, so we'll see if it works. Okay, so I was supposed to have, so I prepared for all of these, right? It was already running the app, and now the app doesn't want to start because RabbitMQ is not running. Okay, let's try this again. Let's do one try. Yeah, it doesn't work. All right, so I'm sorry. So we're going to skip the demo. Today is not my lucky day. But the demo was that, so in February, we released a library, Platform Tech released a library called Broadway, which is about like data ingestion and data processing. So if you're getting data from like RabbitMQ or Amazon SQS, it's very easy to process that data and process it concurrently. And what we did is that we added telemetry integration to this pipeline, and then we could see how many events were flowing to the system. We could update the system and see how it changed throughput. So the demo did not work here, but for those who are interested, Marlus tomorrow, he's going to have a talk on Broadway, and he's actually the one who wrote the demo. I was just going to claim that his work was mine. So I guess it's for the best. It didn't work. So if you're interested in Broadway and on the demo, you can watch his talk tomorrow. I'm sorry. All right, so, so what is next for the Elixir language? And I want to be very clear that at this point, I am talking about the Elixir language and only the Elixir language. I think that the community and the ecosystem is up to grew to a point where there is not one single person that can represent or talk about the community or the ecosystem as a whole. So I don't want to do that. I want to, what I can do and what I should do is to talk about the language. So I'll focus only on the language. All right? So yeah, so what is next, right? So, last year when I said, there was one last planned feature, and then when we released 1.9, I announced that our backlog is empty. Some people, they were worried about what does that mean, right? Does it mean that we'll never ever have a new Elixir version again, right? And no, it doesn't mean that. We're going to continue to have new versions. What it means is literally only that. It only means that the backlog is empty, okay? We don't have any major new features. We don't have anything planned, right? But we will continue to have new versions every 6 months, right? So we have new Elixir releases every January and every July of every year. That's going to continue, right? We still have absolutely no plans for a major release. There's no plans for Elixir 2.0. I'm going to talk about it again soon just to make sure we're all on the same page. And we will continue leveraging improvements and contributing to Erlang OTP whenever we can. Okay, so yeah, it just means that there's nothing major planned, but life goes on. We'll continue improving, continue shipping new versions. And the reason why we can do this is because most exciting developments come from the community. This was true this past year, the year before that, and the year before that, right? And this affords Elixir to focus on two things, stability and extensibility, which were the goals of the language since the beginning. So, you know, if you go to my early talks, I say, like, one of the goals of the language is extensibility. We want to have a language that is small, it's focused, but we can get this language and extend it to a bunch of different domains, okay? So, and you know, if we can do that, if you can have a small language that we can extend to a bunch of different domains, the language can afford to stay small, to stay stable, okay? And that's our plan. But you know, just to make sure that nobody's going to panic and say, oh my God, there's never going to be nothing ever interesting happening in Elixir again, I want to very briefly talk about Elixir 1.10. So we are not working not even for 2 months in Elixir 1.10, and we already have some like interesting changes in there that I want to share with you. So what we have in Elixir 1.10. So those or we're working on right now, or it's already master. So one of the things that we are doing is that we are moving to zero CI. So we have historically tested on Windows and Unix, but now that we have a bunch of shell scripts because of releases, we want to test on FreeBSD as well, and zero CI supports all 3, and that's great. We want to unify everything there. We also added compiler tracing, and we added ExUnit pattern diffing, and I'm going to talk about those 2 with a little bit more of detail. All right, so compiler tracing. So let's wait a second for the code to load. So look at this code here. This code is, if you wrote a Phoenix application or if you worked with Acto, you probably saw some code similar to this, right? So it's defining a module, and then at the top we say we are importing Acto change set, and then we say we want to use the Acto schema features, and then right below that we define the schema with a name field, and then at the bottom we have a change set function that we define, and this change set function calls a cast function. So if you use Acto, you may know that this cast function comes from Acto change set, okay? So what is the issue that we have today? Imagine that you are writing a static analysis tool like Credo, or you're working on an IDE text editor like you know, in Visual Studio Code or whatever, Sublime Text, whatever editor you choose. And now imagine that you're working on those editors and you want that when you mouse over cast, it shows the documentation for the cast function, right? In order for you to do this, you actually need to, those editors, they need to understand the Elixir code, okay? So they need to look at the code and say, oh, I see here that I have a import Acto change set. So this cast is probably coming from there, so I'm going to show the document. And you know, since Acto change set has a cast function, you can say, I'm going to show the docs for Acto change set, right? The cast in Acto change set. But the issue is that use Acto schema is a hook for metaprogramming. Use Acto schema can do whatever it wants with that code, right? So we have metaprogramming. It's restricted to compilation time, so you can do a lot of crazy things, let's say, but it's only restricted to compilation time, right? After your code is compiled, everything is sane, everything is stable, right? So the issue is, since Acto schema can do anything it wants, it can even remove the import to Acto change set, right? So it may be that this code doesn't even compile because it removed the import to Acto change set, so there's no cast function anymore. So what those editors they have to do is that they need to execute Elixir code. They need to start re-implementing the compiler, right? So, you know, instead of doing all of this, do you know what implements the compiler? The compiler itself, right? So the idea with compiler tracing is that instead of having those tools re-implementing what the compiler is doing, we added hooks to the compiler, so the compiler tells you everything that it's doing. So you say, hey, I am importing this module. I am calling this macro. I resolve this import. I handle this alias. So now, since the compiler is telling you everything, those tools, they can just say, hey, compiler, tell me about your life. Tell me about everything you know. right? And then those tools can collect the information. And now when you mouse over, those tools have already compiled the information in a way that they want, and it's going to show the documentation immediately, okay? So, you know, this is a kind of change that is not going to have like short-term benefits, most likely, right? It's going to take a while. Those tools, they have to adapt to use the compiler tracing, but in the medium-long term, they're going to have better and more stable tools, okay? And something else that is coming in Elixir 1.10 is the idea of ExUnit pattern diffing. So in Elixir, since 1.4, we have this great feature which is called ExUnit diffing, which means that when you're comparing two values, like tuple 1 and tuple 2 in this example, if the values are different and the test fails, we show exactly where those values are different. Okay, so you can see, hey, you're missing this information is extra. And this works great, but this feature does not work for patterns. So it works when you are doing the comparison with double equals, but it doesn't work if you're using something like pattern matching. So imagine you have this code. Imagine that you have a feature that has to go to the GitHub gist API, and that is going to return a very big JSON, but you want to check only two values of the JSON that is returned. Pattern matching is great for this, right? Because you can match only on a subset of the map. So if this test fails today in Elixir, this is the report that you get, right? You can't read it. I know, that's the point. It just showed a huge JSON, right? Like, hey, this could not match. Like, good luck figuring out why, okay? And now in Elixir 1.10, this is what you're going to get. So you probably can't read it as well, but you see now. Oh, all right, cool. So we even move the keys that you're interested on to the top, so you can see exactly what you're interested on, and then you have the diff, and you can see, oh, I wrote false as a string, but it is a Boolean. Then you can fix or the test or the implementation immediately. Right, so yeah, so that's it for Elixir 1.10. So we are focusing a lot more on infrastructure, so moving to zero CI, right, working on compiler tracing. But if the community has a feature that they think is important and they want to contribute, sure, we'll gladly accept that. So ExUnit pattern diffing was implemented by Jeremy and Glauber, so a huge thank you to them. All right, so one last thing about what is next for Elixir. So let's just very quickly talk about Elixir 2.0. We talked about it last year, and we're going to talk about it again just to make sure we're all on the same page. So sometimes people, they ask me like, you know, is there a feature that you want to add to Elixir that is going like to change things, and in order to do that, you need to release a new Elixir version, right? And to me, this idea of like a big new feature that requires a new version, a new major version, so implying breaking changes, right? To me, this idea, it's contradictory in the context of Elixir, okay? And the reason for this is exactly because Elixir was designed to be extensible, okay? So if we need a major language version to change the language itself, then we fail to build an extensible language, right? So it's like admitting defeat, like, oh, this thing's not really extensible because if we want to add something, we need to break a bunch of stuff, a bunch of code that the users wrote, right? So, you know, so that's why it's contradictory, right? We don't want to do that. I believe we have a language that we can extend and can move forward without breaking. So when it comes to Elixir 2.0, there are, as I said, no plans for a major release, okay? New features and best practices, they can be implemented today, and that's what we have been doing, right, for the last 5 years, okay? So, and then if there's something that we believe is not a good practice anymore, it's a node practice, we deprecate them. Yeah, and this has been working really well so far because since Elixir 1.0 that came out in 2014, we only have one breaking change planned for 2.0 whenever it happens, maybe in 5 years, maybe in 10 years. It's only one breaking change. It's in our issues tracker, and it's like extremely small. It's like most likely going to affect like less than 1% of Elixir developers. You can check out the issues tracker. It's really not meaningful. And again, when we do this, right, the reason why we're not planning on a major release is because our focus is on stability and extensibility, Opposite to the slide presentation, not very stable. All right, so what is next for me? So now it's my favorite part of the talk, where I can talk about myself. Just kidding, mostly. And so the reason why I usually not a big fan of talking about myself, to be very honest. But the reason why I want to talk about this today is because this scenario, this moment that we are right now, it's a big change to me, because when I started working in Elixir back in 2011, at that moment, 2011, 2012, until 1.0 came out, it was a period where I would consume a lot of information. I would try a bunch of different programming languages. I would read a lot of books, a lot of papers, because I was exploring what was available to try to come up what I think would be best for Elixir. But since Elixir 1.0 came out, this kind of switched, right? I would be producing a lot, right? So I would work on books. I was continuing improving Elixir. I contributed to a bunch of projects in the community, like Plug, Phoenix, Ecto, XDoc, GenStage, Broadway, right? So producing a lot of content, a lot of information, let's say, but not with a lot of time to consume. Sure, from time to time, when we work on GenStage or when we're working on Broadway, I would read the literature and try to get up to date to the best practices, but those would be in short periods of time. But now we are in the situation where, we have nothing new in the backlog. I am not running against the clock anymore, right? So I'm finding that I am in a moment where I can have more time for myself to consume and see what is interesting happening there. So what is next for me? There are two main things, and I'm just sharing for some reason. Maybe it's oversharing. There are two things that I am particularly interested in looking at. So one of them is that I want to go lower in the stack, and I'm going to talk about it soon. And the second one is code analysis, okay? So going lower in the stack, what do I mean by that? So when you write your Elixir code and your code is compiled out to a Beam file, it actually goes through a bunch of steps, for a bunch of representations. So it starts with Elixir, then it's transformed to Erlang representation, then it becomes something called core Erlang, then it becomes kernel, then it becomes SSA, then it becomes Beam. The SSA is relatively new. They added it for Erlang 22. And with time, I was slowly going lower the stack. So at the beginning, I would be mostly at the Elixir Erlang boundary, and then I started doing a couple things with core Erlang, and this year I sent a patch to kernel. So I'm slowly getting there, right? So I want to try to understand the whole process from the beginning to end, to have a holistic view of the whole thing, and see where I can help, where I can contribute, and this kind of stuff. But when I say go lower in the stack, there's something else that I'm interested on, which is native compilation. So we have native compilation in the Beam for a long period of time with the Hype project, okay? And now we are seeing a bunch of interesting initiatives with the Lumen project that we heard today morning, and we're going to have a presentation on Hastega tomorrow. So, I'm interested in those projects. I want to understand what is happening there, but I don't have the background, right? So I want to kind of catch up and be able to see, hey, how can I help, right? How can we make this work best for everybody? So, I want to catch up, and I want to learn more about those things and how it works behind the scenes. And that's one part, going lower in the stack. And the second part is code analysis. So I know dialyzer can be sometimes a little bit controversial. Some people have a little bit not a good experience with the dialyzer warnings. But but there is one thing about dialyzer that we can probably all agree on, is that it's impressive that it can look at your code and find truths about your code, things that will always happen, right? It's a truth, okay? And maybe it doesn't show this truth, or when we violate this truth in a very meaningful way, but this truth is there, right? So the question I ask is, what are the boundaries and the data that we can lift from our code today? Because as I like to say, we write assertive code in Elixir, right? We have pattern matching. We are matching on the struct. So sometimes you're putting explicitly those mechanisms that say, I want to make sure that I'm receiving this, right? So which kind of information we can get from the system, okay? So this is something that I'm very interested on for a while. And I have good news here is that, so Brex is one of the leading startups for corporate credit cards. They started their, they built a lot of their technology in their stack on top of Elixir. They are sponsoring the event. And they're also sponsoring Eric from the Elixir core team. He was the first person to join me on the Elixir core team. He's also the author and creator of the Hex package manager. They are sponsoring Eric to work on this as well, to work on code analysis, to look at our code and say, hey, what can you tell me, code? Let's talk, right? So, so I'm really excited that I'll be doing this with Eric. It's more like he'll be actually the driver. I'll be the passenger asking annoying questions. But I think it will be fun. And we were already able to do some improvements on this from this work, from this collaboration. So in Elixir 1.10, so some of the improvements that we did, they are very infrastructural, okay? But so what we did is that undefined functions and deprecation warnings, they run more consistently. So today, if you call an undefined function or if you call something that is deprecated, we show a warning, but we only show for the code that is in lib. So if you're calling an undefined function in your tests or a deprecated function in your tests, you don't get any warning, which means when that thing is eventually removed, you never got to know about it, right? But now, that happened because this kind of pass would, this kind of check would happen in mix, but now we moved inside to the Elixir compiler. So it's going to run more consistently now. And we have better detections of guards and clauses that can never match. So if you write something a little bit nonsensical, if you write a guard that is conflicting or clause that are conflicting, we are going to let you know. And this works because if you think about pattern matching and guards, they are like a subset of Elixir. They're a small subset of the language, okay? So yeah, so to sum up, our focus is going to continue to be stability and extensibility. This has been our focus for a while, and now I'm making it as official as I can. And this is only possible thanks to, first, the Erlang virtual machine, right? We are building, we built Elixir and we are building our systems on top of this amazing virtual machine. And one of the reasons why we can say, well, there are no major planned features for Elixir is because, well, a bunch of the runtime improvements, compiling improvements, they are happening on Erlang OTP. Right? So we don't have to worry about that. And it's also thanks to the language, right? Because the language was designed to achieve this goal of stability and extensibility. And most importantly, thanks to the community. As I said, the reason why we can afford this is because the most exciting projects, developments, ideas, they are coming from the community. And I've mentioned some examples in my talk. Right, but they're just examples of teams and people that I've personally worked with. I know that there are a bunch of other exciting projects happening in the community, exciting ideas that we are hearing today on the event. I know there are a bunch of events, meetups, when you're talking with our coworker, convincing your company to move to Elixir, we are all part of the community. And we have achieved a lot in those last years, and I'm sure we're going to achieve much more. Thank you very much.